everyone, in today's lesson we're going to talk about how to complete the square to find the equation of an ellipse. Up till this point, you've only completed the square with circles. So it's very similar, but this time we need to get that equation of an ellipse. Remember, an ellipse has x squared over a squared plus y squared over b squared equals 1. Obviously, we could have different variations. The b could be here, the a could be here. The center may not be at 0, 0, but this is your general form of an ellipse. So that's our goal of what we're going to get to. So we're going to work the same way that we started with the circle. First, we'll group the x's, we'll group the y's, and we'll bring the constant over. So I'm going to use red for the x's. So we've got 4x squared minus 48x plus, I'll use blue for the y's, 9y squared plus 72y. And we're going to bring over this 144. So I'm going to subtract it on both sides and make it negative. Now, we know we cannot complete the square unless the leading coefficient, unless that term is 1. So this 4 can't be here, and this 9 can't be here. So we're not taking out a GCF, because then we would be taking out the x's and the y's. We're just taking out that leading coefficient. So I'm going to divide both pieces by 4. And we get x squared minus 12x. Then we're going to take out the 9 with the y's, and we're left with y squared plus 8y equals negative 144. Then we can complete the square. So the goal is going to be to create a perfect square trinomial with the red and a perfect square trinomial with the y's. So we're going to take half of the b value and square it. So remember, your b value is the number next to the x. So in this case, negative 12, and in this case, 8. So if I'll use it over here, negative 12 divided by 2 squared gives me negative 6. Square that gives me 36. Then I take the 8 and halve it. 8 divided by 2 is 4, and 4 squared is 16. So those are the numbers that you're going to add to the left side. So we've got 4x squared minus 12x, now plus 36. That makes this a perfect square trinomial. Then we're going to do that with the y's, y squared plus 8y, then plus 16 equals negative 144. Now, normally I would say whatever you add to one side, you have to add to the other. But because there's a 4 in front, we have to make sure that we are multiplying it by the 36. So watch. We're going to do 4 times 36, and that answer goes here. Then we're going to do 9 times 16, and that answer will go there. So if we just do a quick calculation, 4 times 36 will give us 144. So that's what we add here. And then if we do 9 times 16, that also gives us 144, and that's what we add on this side. So I guess general rule of thumb is if there's a number on the outside, you can't just add the 36 and the 16. You have to multiply it by the number that's on the outside, and then you can add it. So if we add everything up on the right, we have a negative 144 with a positive 144. Those will cancel. And I'm left with that other 144. Now, with the red, we have a 4 in front, and we need to write this perfect square trinomial as something squared. Then we have 9, and we have a trinomial that's perfect that we have to write as something squared. And if you remember with the completing the square process, it's always this half value here that will give us the thing that are the factors. So here, the red is just going to be x minus 6 squared. And with the y's, it's going to be y plus 4 squared. Now, we're almost done. The idea now is to get this ellipse to equal 1. So all we really have to do to finalize this answer is get this 1 over here. Well, how do we do that? We have to divide every piece by 144. So whatever you do to one side of an equation, you can do to the other. And when I divide 144 by 144, we get 1. Now, in your calculators, you can divide 9 and 144. And if you do that, you can reduce this fraction, the 9 over 144. So go ahead, take a minute and do that. Pause the video if you need to, and then hit resume when you're ready. So when you reduce it, you should have gotten 16, or 1 over 16, which would be on the bottom. And then same thing over here. We're going to divide 4 and 144 and simplify that fraction. If you do that, you should get 1 over 36, or just 36 on the bottom, and x minus 6 squared. So take a look at what you just found. You now have an ellipse that is equal to 1, and a center at positive 6, negative 4. 36 is a larger value, so this would open horizontally, right? So we've got a whole bunch of information that we can get from completing the square. So I'd actually like you guys to try example number 2 on your own, and then hit resume when you're ready for the answer. All right, take a look at the work. All right, a couple things that I want to point out is that the x squared didn't have a leading coefficient other than 1. So there was no need to take out the leading coefficient like I did here with the y's. So when you're adding to both sides of the equations, because you're not taking out a GCF over here, you can add 1 to both sides. That's okay. So in the second one, since you took out the GCF of 16, we had to multiply 16 by 9, and that gave us 144. So this is a great example of a mixture of the two different types. So you really have to know your stuff when solving this. A couple of things that you can figure out at the end is that the center is -1, +3, and that the A and the B values in this case are 16 and 1. I just noticed there's a mistake here. 16 divided by 16 is actually 1. So here, this denominator should be 1. If you want to write it nicer, it would be x plus 1 squared over 16 plus y minus 3 squared equals 1. And that actually would be your final answer for the ellipse. Again, it's ugly, it's not pretty, but obviously this would be the larger number, so a would be 4. Putting this over 1 would mean that the b value would be 1. All right, that's it for ellipses. If you have any questions, now's the time to jot them down, and make sure you ask us in class tomorrow. All right, have a good night.